So Lisa's back in her cage now because that's the end of her lessons, I think, for today. Um, hopefully your eardrums are okay. All right, so for large stars, we're talking about stars that are above 1.4 solar masses, so 1.4 times the size of our sun. They have a very similar start. So they start off as a nebula and they contract into a protostar, which then starts hydrogen fusion to become a main sequence star. But it's going to be a much bigger main sequence star. It's going to be burning very bright, and it's not going to last as long. So what happened then? Well, it also just basically forms a supergiant. So it does exactly the same thing. The hydrogen runs out, and the core collapses. And when it does that, you get the same process. You get a supergiant though. So rather than a red giant, it's a red supergiant. It's just much bigger, and it's also red. Okay, so we've got that happening. What happens next? So basically, that central section then is, basically you can start actually fusing heavier things. So you can get carbon and oxygen and nitrogen being fused. So that's our CNO cycle again. But it can go further in a bigger star because it's hotter and there's higher pressure. It can go all the way up to iron. Once you get to iron is incredibly stable, and it's very hard to break or do anything with those nuclei. And so the star basically doesn't have enough energy to do anything with it. And so it runs out of fuel at that point, and the core collapses again. Now, as it collapses, this is what we term a supernova. So a supernova event is where you get the supergiant core collapsing, and the shock wave actually extends out through all those outer layers of the supergiant, and there's enough energy in that shock wave that it can actually cause the material that's in all of those layers to fuse and make even bigger elements. So this is where anything bigger than iron comes from, which is kind of cool. Okay, so what happens then to the center? Well, it really depends on how big the star was. So if it was like a big star, it's going to form a neutron star. And if it's even bigger than that, and we're talking I think above 5 solar masses, it's going to form a black hole. So a neutron star, basically, your protons and your electrons are going to squish together, and everything's just going to turn into a big neutron soup. It's incredibly dense, releases a lot of radiation. A black hole, as we know, is basically there's just so much mass and so small an area that the force of gravity is so strong that not even light can escape from that. So that's what's going to happen to really big stars.